Okay, so what I wanted to do today, after giving you the dose of this theory, is I wanted to deploy a model, right? And when I say deploy, because the model is already pre-trained. And when I say pre-trained, I wanted to show you an example. What does it mean by pre-trained, and what does it mean by deployment? So I want to start with something called this, and I think Shruti used that, and she's not here, so I'm using her method or whatever she described earlier as an example. So in this scenario, this model is Distilbart CNN 12.6. Again, don't go by what it is and what it is, how it's pronounced and how it's being written. There is a site called Huggingface. Any one of you have heard of Huggingface?
So, yeah, in the
Okay,
last session you told about this. I think it's
okay,
MLOps GitHub.
correct. So just wanted to correct it. It's not MLOps GitHub in a way, right? It's the single location for machine learning model repository, and they are expanding. They started with a model, and then they got into a data sets, and then they got into a spaces and whatnot, and now they are selling the solutions as well. But it all started with a model. So if you are a model developer and you want to open source your model, you would go and upload it onto GitHub. Sorry, it used to be GitHub, but Hugging Face created very simple, easy to use interfaces where people like you and me started putting or pushing their models into Hugging Face. And here there are so many tasks and the libraries and the data set. They have given out the filters here. But if you want to do image classification, I think in your Apple case, for example, right, Salman, if you just click on the image classification, there are like 1,148 model as of now exist. And each model, and let's take this for example, right, the Microsoft Weight Base. This fine-tuned model, it's fine-tuned. When I say fine-tuned, I'll give you an example. There is a thing called ImageNet that has a 22,000 images, or it used to be. They have 14 million images and 21,000. Yeah, so 22,000 is the classes. So each image may have a one or two class, depends on whether that apple, it's green apple, red apple. So it can have two class. One is apple class, the second is red or green, right? So similarly, there are like 22,000 classes of each image, and there are like 14 million images Microsoft used, and they train that model using those 14 million images, and they created this model and they made it available for you and me to use it. Okay, so it's free to use in a way, right? Again, it's from Microsoft, and there should be a licensing. Okay, there is license. It says Apache 2.0, so that means yes, you can commercially even use it. You can modify the source code if you want, and you can use it as is as well, whichever way you want, right? So that's just one example, and there are so many descriptions they have. I mean, each model has its own description, the model card, what is the accuracy, and how you want to use it, train it. If you want to train using your own data set, in addition to the ImageNet data, what's available, and how would you do the pre-processing, pre-training, and what are the citation if you want to give credit to the author of this model, you use this citation to do that, right? Along with that, there are many others. So I don't think here they have a, yeah, we can do an inference as well. Let me see if I have an image which I can pull in. So remember, we were doing that image classification last time as well. Yeah. Come on. All right, it's taking its own time. While it's taking, it will do its inference, and it will probably give us a classification from that. Okay, it's a farm, it's a cow or an animal, and it will throw out bunch of classes what has been predefined into this ImageNet 22K. Okay, there we go. Calf, orphan, dairy farm, cow barn, and with some accuracy or the, oh, this is computation time only. Yeah, probably in a bigger JSON output, probably you might see the accuracy of what is the accuracy at which they think this model is performing or giving you the right answer. Similar to what we saw in recognition, but that was just for recognition or translation, what we saw in last class. But in this scenario, we are looking at literally 90,000 different models, right? And it's growing. Any day you build a model, you can upload your model into Huggingface. It's free to upload, similar to your GitHub code, free to upload. And there are many functions, many tasks you can do. And that is what we wanted to do today is summarization. And the reason summarization, again, not to pick what Shruti was saying, but primarily that was the simplest example I could think of. And it's very easy to replicate. So I thought, okay, let me at least come up with a use case and show you how we should be doing it. Okay. So with that, let me see if I can show you the code and then we'll get started. Give me a second. If I can move this guy over here. So can you see the GitHub?
Yeah.
Okay. I'm gonna send this in a chat, this GitHub URL regardless, and then I'll paste it in the Slack as well later. But for now, this is the simplest code we can think of, right? What I'm doing is, are you all aware of Dockerfile?
Yeah.
Yes.
Yes.
You created a Docker container, at least somewhat, right?
I mean, only if homeworks are done, right?
So here is a surprise, okay, and then surprise is coming to Sridhar's way. Sridhar, I have this Docker file. Can you help the class understood what actually this Docker file is doing? And I know you are seeing this line or this Docker file for the first time.
Yeah. So how about we pick a volunteer and ask, see if somebody's comfortable explaining this.
Okay, I like that as well. So
I'll be
instead of
here.
you being a monitor, yes,
Yeah, I'll be here to validate that or help out.
Okay, who wants to be the volunteer?
Salman, Shruti, Nishit. I think we lost Shruti. Yeah, it's only between Nishit and it's only between Nishit and Salman, right?
Okay, if they are not volunteering, they are being voluntold.
Yeah, Nishit, I know you said you didn't have time to do all the homeworks, but how about you give it a try now? See how much you retained from our first week and or 2 weeks.
So I can guess here. What I'm thinking is like first line is the NVIDIA framework that we are planning to get from NVIDIA image that we are planning to get from the open source, that is from the Docker.
Okay.
And then we are trying to install the updates first. Because first in the when we did that homework, first we actually updated all the latest versions of the software and everything, all the suggestions and all the recommendations. And then next line is install unzip. That I'm not pretty sure.
Okay. Yeah. Ignore 11 and 14 for now because we did not talk about them.
Okay. And then we are installing the Python to that Docker image. And we are setting the working directory, copying that. And so not sure about if they install no cache directory requirements. This one you said
Yeah, it is mostly what line number 19 and 20. You're setting up an environment variable for your language. You're setting it to UTF-8.
Okay, so what I understood from here is like we are taking the NVIDIA image here and Ubuntu image here,
okay,
and installing Python on top of that.
Bunch of apps, yes, and you're setting the work directory to be var app.
Yeah. Okay.
Right.
Yeah.
And then everything will be copied to that current directory. And then again, you're reinstalling. Sorry, you're installing all the requirements, and then you're setting your environment variable, and you're exposing the port 80, like we talked about, right? That is what we have to export within a container to the host.
Yeah.
And then the last one is what you're actually running your kind of entry point. Whenever it runs, that's the first command it gets executed. In this case, what you're doing is gunicorn, which is an Nginx based web layer for your Flask applications, and then you're starting it and binding it to port 8080. And you're again, it comes with a bunch of workers, so you're even starting the workers as well here. So basically, the line number 26 is nothing but you're initiating your application. Simple.
Okay.
Yep.
Salman, any questions?
I mean, I'm not exactly sure as well, but I think I agree with like Nishit also. Like, I think it's the same, whatever he said.
So Nishit said that Salman did not do homework in between. So you agree with that too?
I mean, I tried to do it, but I'm not sure.
Did you ask any questions in the Slack?
No, I didn't.
Okay. Now at least you will be forced to ask now for this one. This, I think, over to you.
Yeah. No, I think so. In a nutshell, right? As Sri was explaining, it's taking a CUDA container. That's the first line. It's installing a bunch of things. It's installing the requirement for that Python application. When we say pip3 install, and it's waiting for read from the requirement.txt, and this is bunch is fine. And finally, it's exposing as a port 80 and then starting an application, right? That's the thing it's doing. So you looking at this container, can you tell what it is doing? I mean, it's using CUDA, some sort of an NVIDIA, so maybe some GPU, it's doing Python, but we don't know what exactly it is doing, right? From a function point of view. When I say it's we want to do a summarization, do you think it's doing summarization here?
Not sure.
Yeah, we don't know that, right? Yeah, so we don't know that, and maybe it's written in one of this app, right? Because whenever that Python application get launched, is exactly where we'll need to find out what it's doing. So before we go into that app, I just want to show you requirement.txt, right? And I hope you can. It's big enough. So it's installing a bunch of the Python libraries, Pydantic, UVCon. We saw GUnicorn is the fast API is what we are going to use, or it's gonna get impacted from a usage point of view when we hit the API endpoint. Torch is something I wanted you to get familiar with. So I think It was Salman. You said TensorFlow when you were explaining your use case, correct?
Yeah.
On that day when we talked about, we also talked about something called PyTorch,
Yes.
right? So here we are not using TensorFlow as a framework, but we are using PyTorch.
Okay.
Okay. And sentence piece, we will come to it later. But what other thing I wanted to explain you is transformers. So transformers is actually change the life of a machine learning. When we if a history will be written, whenever that history will be written around machine learning for last 15 years, transformer is the life changing element, and Hugging Face is the company behind the transformers, right? So whatever we are seeing here, the model being developed and used, and then transfer learning is being applied. It's all result of a transformer, and we are going to launch the transformer library as a result of as a part of our container. Now, this still doesn't tell us what exactly we want to do, right? It's launching certain libraries as a part of the requirements, and Python will say, okay, I will load those libraries for you in that container. But what actually it is doing, uh, before I go to app.py, I wanted to at least bring in the transformer or highlight some of the transformers and the tokenizer, what we're going to use it here. So what we are doing is we are importing the pipeline from the transformer pipelines. That is again Hugging Face. We are also importing the tokenizer and the model, which is in this case sequence to sequence language model. What we are doing as a part of the tokenizer and model is again, this is coming from the transformer libraries. We are asking that get me the tokenizer from Schleifer. I don't know how to pronounce it. SSH Leifer, if I use the word. Distill BART CNN 12.6. So, oops, where it is here. All right. SSH for distill BART CNN 12.6. So it's gonna go, and then considering this is coming from this transfer library is from Hugging Face, so it knows that what to do. So it will go and pull the tokenizer. It will go and pull the model, and it will save that pre-trained model, and it will save the pre-trained tokenizer, right? And once we know, then once we have this model and the tokenizer, then we can write our app. And that app is again written in simple Python, where all again, I'm not gonna go through all of the functionality here, but we are using a fast API just so that we can bring in the API endpoint. We are using CUDA. Again, CUDA is part of your NVIDIA driver to simplify it, right? And we are telling that torch device is nothing but CUDA. If CUDA is not available, then use CPU. That means if GPU is not available, then use CPU. But for now, we are saying, okay, it's a, and then I'll show you to how to do this deployment in and how to do the inference on a CUDA device. So then we are bringing in our tokenizer model, what we had brought in from that earlier file, what we saw. And we ask that model to run on the torch device. The torch device is the GPU. So now that model is running, and it's expecting, so once the model is run, it's expecting some text in a string format. It's expecting the minimum length of and maximum length, two integer values expecting. And there are some functions defined here. This function is for the summary. So what it will do is it will generate a summary from that text. So the tokenizer summary, which is a function into the model which this gentleman or the lady has created, right? Maybe the picture is of gentleman. And it's gonna use that tokenizer summary. and generate the summary value. And once you see the example, you will figure it out. But it will generate the summary value and it will send you the output. So what does it mean by generating a summary, right? So let me see if I can bring something here. Where is my, this is still my Chrome. Can I go to a different window on a Chrome? Come on. Okay, here we go. And this is my Wikipedia, right? Okay. So I'm just bringing this page here. So this is a Wikipedia article. Everyone is aware of Wikipedia? I'm assuming yes.
Yeah.
Okay. And if we want to, let's say this is 2 paragraph, right? Or 3 paragraph, if you want to say this. And if you want to summarize this, now 3 paragraph is nothing. You don't want to summarize a 3 paragraph. Rather, you want to summarize from this 20 paragraph into 1 paragraph most of the time. But for simplicity, we will say, okay, we want to take this 3 paragraph and we want this model to summarize in a sentence or maybe 2 sentences at best. And which is what we will do. I'll take this text as is and we will summarize. But what I wanted to tell is we are feeding the text to this model and that model is going to generate that summary. And this is just a couple of API endpoint. One is the root that just to show that this is working, and one is the summary, which is where we're gonna hit the summary, which will give us the summarization, right? So again, this is a very simple Python code, and it's giving us the result. So what next I wanted to do is, can I share 2 things at the same time? Let me see, give me a second. Pause share. Stop share. Share a screen. Okay, I'll need to do a desktop that way. Otherwise, it will be difficult. So this is my 1, this is my 2. I'm gonna bring this guy here, desktop 2. Okay, can you see something? Still see something on the screen?
Yeah, we can.
Okay, all right. So I already have a, and I'll let me start with the how it's working, and then we will figure out how to deploy and whatnot. But I already have this Docker run, what we were looking at earlier, right? So if I go back to here, and if I go back to the Docker file here, right? We requested that it runs on 0000 on port 80 and expose your port 80. So I said, okay, where is my terminal? Okay, Docker run port 80, container port 80, and I'm saying, okay, use all GPU, and summarization is my container name, okay? Just for simplicity, I made the name as a summarization. And since this is, what was the IP address? To make it easy, first I'm going to go to this IP address. Okay, and I got a JSON blob saying that message, this is working, right? Can you see it? It's very small on the left, top left corner. Yes, no? Anybody? Did I lost you all?
No, we are here.
Okay, can you see the message, this is working, something like that?
Yeah.
Okay, it's visible. So all I did is I'm connected to this EC2 box, and I have deployed this app what we are talking about. I'll peel the onion in a second, but just wanted to start off with what it is doing, right? So if we go back to that app.py, where we say anything with /root, show this message, right? Return message, this is working, and that is what we got here. Message, this is working, right? And when we hit the /summary, we should get some result. But this method is not allowed because summary is expecting a post method. If you see here, it's a post request. This is a get request. And again, if you don't know what is get and what is post, I highly recommend to go through some of the HTTP methods like HTTP get and HTTP post. And that will give you a more broader idea of what it is. But I'll show you what I'm doing here in something called a Postman. So Postman is a tool which is used for some sort of any API you want to develop and you want to test those APIs. You would typically use a Postman. And what I'm doing here is I'm sending, instead of a get request, I'm sending a post request. And I have a header. I added a header called content type. So I typed it manually actually. The moment I say content, it's going to give me an options and say content type. And since I'm going to supply this data in JSON format, because that is what our application is expecting. So I'll say application JSON. And in the body, I'm sending a message, which is again JSON blob into parentheses with a text as one field with that Catherine Dwyer Sullivan. So if I go here, I took this 3 paragraph, right, all the way from here to here and formatted it in a way. So it's a single line. And I'm saying minimum length is 75. That means here, the length of the result I'm going to get is at least 75 character and maximum length of 150. And if I send this request, it will go and hit this server. That server is whatever that IP address, which is our EC2 instance. And I'll show you what all I did in a second, but I wanted to show you the summary. And send, it's loading, and we got a result, right? And it's saying its device is CUDA, so it performed that functionality on a GPU. Now you can say, hey, this you already had tested it out. I want to try with something else, right? So why not? What is the favorite page of anybody? Thanksgiving? Okay, let's take this, right? And I'm gonna get this out and I'm gonna do a inline editing so that we don't get all kind of errors. Okay, so this is in a proper JSON format in a way, or at least the text blob is. And I'm gonna still leave this remaining as is because only my data is changing, right? And then I'm gonna send a blob and we have a summary of this entire paragraph or 2 paragraph, whatever it was, into 2 or 3 sentence at best. So my question is summarization, assuming this is working, right? Where can you use this? In real life, other than this practical example? Okay, let me show you an example. Oh, when is Thanksgiving? I'm not asking, I'm asking what is Thanksgiving? So what is the true meaning of Thanksgiving? Let's say this is the question, right? What is this? What you see here on this screen?
Summary.
Exactly. So this is the summary of this page. So this page may have like 300 words, 500 words, who cares, right? User are not looking to go into that Britannica page and then read through what it is. They are looking for a summary answer. If you give them summary, if they are satisfied, they will move on. If they are not satisfied, they will click that link and then go inside that page and read through, right? But summary is what everyone is looking for. Now, this is just a search, but in any scenario you can come up with, summary has very active use case when you see the text. Whenever there is a text-based model, summarization is very highly utilized and very heavily applied use cases. Is it making sense?
Yeah.
At least from a use point of view. Okay. All right, so let's peel the onion, how we got here. First of all, is it understood that what we got, or we need to explain one more time?
One thing actually I was not clear is how the summary is happening.
Okay, so that's, go ahead.
Yeah, we are calling the method inside of that Py file, a Python file. But actually how the summary is working. So which ML framework or the services, right, it's using.
So two things, right? One, it's using, so in this scenario, this model was trained using PyTorch, the framework. The model is built on summarization. It is a transformer network, right? From a network point of view. It's using text-to-text generation. It's using BART as a data set as well. And there are many other items you can go through. So particularly BART is one of that. That is where the model card comes in very handy. And you can read through this of how BART works and how BART was designed from a design point of view and how it get applied in a real life condition, right? So there are like, again, there may be 10,000 different model. Again, Huggingface may have only listed few hundred, but there might be 10,000, even 100,000 different model. Huggingface, at least in this scenario or in this transformer version, they are supporting whatever X amount of model. So this is one of the text model. If we change it to Albert model, for example, and if Albert is also doing summarization, and when we do a summary of this page, we may get exactly that, or we may not get this also, or we may not get this many, who knows, right? So that is based on how that model was trained and what kind of data using that model was trained, right? So in this scenario, we are using a pre-trained model with public data set or whatever the data set they got hold of at the time of building that BART model. Am I making sense? So yeah, for that you need to go deeper into what is this BART model is. It's saying they inherited from a pre-trained model. Which pre-trained model? So if we go further into the pre-trained model, and probably they will identify that which all pre-trained model Huggingface is using or that author has used, right? And what parameters they used to train their model. So being an open source, you will have a lot of visibility of what this model is, what that model does, and how it can be applied in a real life. Because it's an open source. This, in 5 years ago, if you ask me this, probably this never existed. And people used to scramble. There was only a small set of community of people who would know, and that community used to call data science. So what's happening here is that data science community is kind of democratizing, and any engineer can go and train a model or run a model. I hope I was able to answer your question, Nishit.
Yeah, but in the file actually where he's referencing that PyTorch library or
Okay.
services.
We will see this. We will see this. So let me go back to this summarization where I'm telling it, first of all, that, okay, I need So first of all, I'm telling this summarization. So let me do this. Instead of going through this, let me go through the steps what I want to go through, and then we'll go to each step by step, and then you can ask question. That's fine.
Yeah, that's fine.
Okay. So this is a step. Again, this is a public GitHub repo I have created for you, and you can do it on your own GPU. But the moment you launch a GPU, it's costly. So be careful. What I want to do is I'll stop this container. So, okay, now that container is stopped, and if I hit this send, it should fail. Okay, could not got any response, right? That means our container has stopped or something is wrong. But let's go step by step. So if what I did very first thing is I was here and I'm going to remove my ML folder. If it works, great. If not, blame it on me. What I'm going to do is I'm going to clone this repo on my local EC2 box. Git clone. Okay. Okay, so now I got the ML folder. I am on the ML folder now, and I have all this file. What we see here, we got it here as well, right? And this server is in UTC time. That's the reason you see 224. If I do a date, it's 224, right? That's why. So don't get surprised. I'm not working at 2 a.m. But let's go through our steps. So what all we need to do. So first we want to get make sure that we have Python there. Okay, we have a Python. Let's install Python PIP. Do we have PIP3? Okay, we do have PIP3, so we don't need to install Python because this node was already recreated or at least pre-created before this class. What we want to do is we want to install certain libraries. So the one library we want to install is transformer libraries. So transformer libraries is when we install this transformer library, we are telling that this transformer library is nothing but a Huggingface transformers. That is how it's being defined. But since this node already has transformer library installed, it's saying requirement already satisfied, right? Otherwise, it would have installed. Then let's clear the screen. I'm saying install torch, which is PyTorch, right? So here I'm telling that, okay, I want to install a PyTorch and then version 1.9. It's saying, okay, PyTorch Torch 1.9 already exists. Next, what I wanted to do is I want to show you what all we have so far, first of all. So what we have, same content what we have in our GitHub, summarization, steps, requirement, app.py, readme, MD, and Docker file, right? Next, I want to, I can do multiple way, but in this scenario, it was easy to write a Python file and then do it. Is from the transformers.pipeline. So I installed the transformer first. So I'm saying from transformer.pipeline, import pipeline, right? So I need a pipeline library. And I also need auto tokenizer and auto model for sequence to sequence language model. So those are the two things I need for bringing in my tokenizer and model. So what I'm telling is next step is define this variable of a tokenizer as auto tokenizer from pre-train. And all I'm telling is from that, because auto tokenizer is coming from transformer library, it knows that I have to go and look for this thing on Huggingface, right? So if I change that to, and I'll change it in a second, let me download what I want to download first. And if I change from first distill bar to CSAB Butte NLP MT5, then it will download that model. And whatever the Ansible for that model. Okay, so I'm telling here that go and download DistilBart CNN 12.6 from SSH Leafer, and also download the tokenizer for both. And this is just a saving command or some sort of a function, that model.save and tokenizer.save. So when I execute this Python file, see what we have so far in this directory are this 6 files only, right? So what it will do, it will go to this website and it will download this model and the tokens, the tokenizer. So here we go. So we got a new folder here, DistilBart CNN 12.6. What does it have inside? So it has this PyTorch model. It has a bunch of configuration. It has the tokenizer. We can read through tokenizer if we want to. Okay, tokenizer is this in the JSON format, and there are so many words. And for each word, they have a number given, right? So token is nothing but a word, if you think from a machine learning language point of view, right? And each language model typically comes with a vocabulary. So there is a vocabulary of how to use that vocabulary, and then changing the tokenizer, changing the vocabulary will change the accuracy of the model. Okay, believe me, I've done it many times where the moment you change the vocabulary, suddenly your accuracy is wrong. So again, this is all it downloaded, and there are so many other components which we are not going to look at it, but this is the model. If you see, that model is from a size point of view, is it 1 gig, 1.2 gig, right? If I'm doing my math correctly. So this is kilo mega gig. Yep, 1.2 gig. So this is a large model from language point of view. And it needs to fit into the memory of your server, because when we start the container, it's launching everything in a memory. So Nishit, to your question, now it knows that this is a PyTorch model. Now it knows that this is where the model is, right, in this directory. And what we are going to do, the next step is we got this done, step 3. We are going to build a container. So whatever we have in this folder, in ML folder, I'm going to make it as a part of my container. So since I already have a summarization as an image, I don't want to build another image called summarization. I want to build something new so that it goes through the entire steps. And this you remember, right? How to build a container, or how to build a container image from one of the lessons Sri was teaching a couple of weeks ago.
Yeah, I remember that.
Okay, so this is the Docker build, T being the tag of that image. So I'm giving the name summary as a tag. I can also do like this, summary : latest. Just for simplicity, I'm going to remove that and then leave it as is. And a dot is kind of an indication that whatever is in this current folder, right? So let me come out. Current folder is my home Ubuntu ML. And in that ML folder, I have this 6 file, what I downloaded from the GitHub. And I ran that summarization.py, which kind of downloaded the model. And I'm going to build that model using all of this. That's it. It's not going to build from anywhere else. That's it. With me so far?
Yeah.
Okay,
Yeah.
so it's going to do its magic, right? It will take its own time. It will do XYZ, 10,000 things, like get an entire CUDA container and install all the requirement, what we had asked from a Python and PIB point of view, and it will also copy that model. See, that's copying from here to there, right? So it's 1.2 gig file. It's taking time, right? Because that model itself was large, 1.2 gig. So it's taking its own time to upload that model as a part of your image. And it's installing the things from the requirement.txt, right? So in requirement.txt, we had like a pydantic, uvcon, junicon, or G-Unicorn, the Fast API, and also the Torch framework. So Torch framework is bigger. If you see, it's 831 megabyte. So it's downloading all of that. And then finally, it will build that image and it will make those image ready for us. So final is building almost in the last stage. So while it's building, any questions so far, what you got?
I have one question.
Please.
Like previously, you opened the vocabulary file and all that.
Yes.
In that, all the words had G at the start of it. Like, so I didn't understand that thing.
Yeah, again, that varies from model to model. We can look at the vocabulary file at the end to see what other content that has, right? Yeah, but yes, you are correct. It is it may be the sequence at which they have defined from G to H to I to G and whatnot, right?
Oh, okay.
Yeah. But yeah, that's a good observation. Okay, so successfully built an image and successfully tagged summary colon latest. So let's verify it. Docker images. Okay, there are so many, but we see summary. Okay, 8 seconds ago. So that's us. So what we want to do is, let me clear the screen. Okay, Docker run, right? Remember that? -p, that is the port on which, and whatever the port you are running in a container, I'm saying GPUs all and summary, because remember our image name is a summary and it will start. It's running on port 80 on the container, and we are exposing that port 80 locally on our server. So okay, sorry, let me go back. So it's saying, okay, application startup is complete. That means server is ready and ready to accept the connection. So come on, there it is. Okay. So if I just go on the home page, this is working, right? That means our web server, whatever the Nginx and the G-Unicorn we launched is functional. And if we go and do a post request, again, we'll still use the Thanksgiving, for example, and send. And we should see the summary, and we see the summary, right? Let's do one more example, like the exact thing what Google did here, right? What is Thanksgiving? What is true meaning of Thanksgiving? So maybe I'll take this entire article here. So they already have created a summary section. Read a brief summary of this topic. There we go. Again, it's very useful in the publication. People, if they don't want to do everything what's available on an article, so I'm gonna take everything and I'll need to reformat a little bit. Okay, there we go. Here up to the punctuation mark. What I'm going to do is I'll quickly jump on to my Visual Studio Code and see if I can. It was too much for my Visual Studio Code, looks like. Yeah, it crashed. I don't know why. New file. Okay, I think I have enough. Let's see if this works. And if that text is payload is enough. Sometimes payload may be too much. Yeah, it's still showing me as a different line numbers. I need to have a single line. Let me fix that. You know what? I'm going to remove all this just to make it simple so that I don't waste your time. Okay, finally, we have a right JSON file. I'm going to send this. Not bad. But I don't know what is this. Learn about tryptophan to debunk the myth that eating turkey induced drowsiness on Thanksgiving. Okay. It does came up with something. I don't know how meaningful it is, but you see the result. So what questions I can answer? I know we talked a lot for last, and I was showing you with some example. What anything else I can answer here? You want to see that vocabulary file? Oops. Okay, Salman.
Yeah.
I don't know why, what they have. This is their own way of defining vocabulary. Each data set may have their own vocabulary of how they want to train the model. So it's this is how they are defining this vocabulary. But yes, oh, come on, and maybe some garbage. Maybe it's the screen is not able to portray it correctly because it's a large file. Okay, so the homework, you need to build this model and you need to run this on AWS or even on your local server, a local laptop, if you can. Can you do that as a homework?
Yeah, we can try.
Okay.
Yes. So we just like follow the same steps as usual.
In a way, yes, follow the same step. The only warning I have is, I'll show you one thing, which definitely will not work, is CUDA, right? Because in this server, we have an NVIDIA GPU. I don't know whether you have an NVIDIA GPU in your local host or whatnot. Do you have an NVIDIA GPU?
No.
Like in my own like personal PC or?
Yeah, on your PC.
Yeah, I have no GPU.
Okay, okay, very good. Then you should be able to do exactly like this. And Nishit, assuming you don't have a GPU on your box, you would need to change this to like an Ubuntu 20 image instead of a CUDA image from the Docker Hub. You need to find Ubuntu supplied image and use the Ubuntu 2004 image and see if it fails. I have a feeling that it should work, but it may fail, may give you an out of memory or whatnot, because remember here, it's defining torch device as a CUDA, but if you don't have a CUDA, it's going to use your local CPU. And in the worst scenario, probably we will open up that AWS account, what we have, and will give you an access, and you can launch a GPU box for 45 minutes to 1 hour and run it on that box. Right, but that's the last scenario. If we are not able to do it between now and Thursday, and if you still cannot do it on Thursday, then we'll come up with that mechanism. Okay.
Okay.
So with that, hope this was clear enough. So just to recap, what we did is we got a model from Huggingface. In this scenario, we got this Distilbart CNN model that is used for a task called summarization. It's a PyTorch model. We took that model, we built a container using that Huggingface transformer library using PyTorch. We saved that model in locally, and then we built a container and we ran that container. And once the container was running, just to test whether it's functioning or not, we connected with that local host or that IP address of that host to see whether this is working. And once it is working, we wanted to do a post request. Again, this is an HTTP post request. We can do it through command line, but it's easier to do it using a tool like a Postman, where we fed the header as a content type application JSON, and in the body raw content with a text as a key, whatever the text we want to provide as a value, min length of a value 75 in this case, and max length of 150 as a value in this case, and we feed that JSON and we ran that as a post object. And since we stopped, we could not get a response, but we got the response, and eventually we were able to see the summary of this 500 word into somewhere around 75 to 100 words. Okay, so that's it for today. Hope this was helpful.